Hello everyone, welcome to my lecture. Today we will discuss about tuples. In this lecture we will discuss about mobility and tuples and assignment. First we will discuss about mobility and tuples. So far you have seen two compound types, strings which are made up of characters and lists which are made up of element of any type. One of the difference we noted is that the elements of a list can be modified, but the characters in a string cannot. In other words, strings are immutable and lists are mutable. There is another type in Python called a tuple that is similar to a list except that it is immutable. Syntactically, a tuple is a comma-separated list of values that look like this: tuple equal ... Although it is not necessary, it is conventional to enclose tuples in parentheses. To create a tuple with a single element, we have to include the final comma. This is look like this one. Without the comma, Python treats a as a string in parentheses. Syntax issue aside, the operations on tuples are the same as the operations on lists. The index operator selects as element from a tuple, and the slice operator selects a range of elements. But if we try to modify one of the elements of the tuple, we get an error. Of course, even if we cannot modify the elements of a tuple, we can replace it with a different type of tuples. This could be like this one. And there is the another example without the comma. Python treats a as a strings in parentheses. This look like this, and that one is. But if we try to modify one of the elements of the tuple, we get a error. This is look like this one. Of course, even if we cannot modify the elements of a tuple, we can replace it with a different tuple. That is must look like this one. And now we will discuss about tuple assignment. Once in a while, it is useful to swap the values of two variables. With conventional assignment statements, we have to use a temporary variable. For example, to swap A and B, this is like this. And if we have to do it often, this approach becomes cumbersome. Python provides a form of tuple assignment that solves this problem neatly. This one. The left side is a tuple of variables, the right side is a tuple of variables. The right side is the tuple of values. Each value is assigned to its respective variable. All the expressions on the right side are evaluated before any of the assignments. This feature makes tuple assignment quite versatile. Naturally, the number of variables on the left and the number of values on the right have to the same. This is like this one. Thank you everyone. In this lecture, this is that. Please join me to my next lecture. Thank you. Hello everyone, welcome to my lecture. Today's lecture is also about the tuples. Today we will discuss about the list of random numbers, counting, and other things. First we will discuss about list of random numbers. The first step is to generate a list number values. Randomly takes an integer parameter and returns a list of random numbers with the given length. It starts with a list of n zeros. Each time through the loop, it replaces one of the elements with a random number. The return value is a reference to the complete list. This one like this. We will test this function with a list of 8. For purpose of debugging, it is a good idea to start small. The random list, this one. This generated by random are supposed to be distributed uniformly, which means that every value is equally likely. If we divide it, the range of possible values into equal sizes brackets and count the number of times a random value falls in each bracket, we should get roughly the same number in each. We can test this theory by writing a program to divide the range into brackets and count the number of values in each. Now the counting. A good approach to problems like this is to divide the problem into subproblems and look for subproblems that fit a computational pattern you have seen before. In this case, we want to traverse a list of numbers and count the number of times a value falls in a given range. That sounds familiar. In the other lecture, we wrote a program that traversed a string and counted the number of times a given letter approach. So we can proceed by copying the old program and adapting it for the current problem. The original program was count 0, this one. The first step is to replace fruit with list and char with num. This look like me this one. That doesn't change the program, it just makes it more readable. The second step is to change the test. We are not interested in finding letters. We want to see if num is between the given values low and high, like this one, of course. The last step is to encapsulate this code in a function called in bracket. The parameters are the list and the values low and high. This one. By copying and modifying an existing program, we are able to write this function quickly and save a lot of debugging time. This development plan is called pattern matching. If you find yourself working on a problem you have solved before, reuse the solution. As the number of brackets increase, in brackets gets a little unwieldy. Now we will discuss about the many brackets. As the number of brackets increase, in bracket gets a little unwieldy. With 2 brackets it's not bad. This in bracket low and high. But with your brackets it is getting cumbersome. It's like 1 bracket 1 bracket 2 bracket 3 bracket 4. There are 2 problems. One is that we have to make up new variable names for each result. The other is that we have to compute the range for each bracket. We will solve the second problem first. If the number of brackets, num brackets, then of each bracket is 1.0 slash the num brackets. We will use a loop to compute the range of each bracket. The loop variable I counts from 1 to num brackets minus 1. To compute the low end of each bracket, we multiply the loop variable by the bracket width. The high end is just a bracket width away. With num brackets equal 8, the output is this one. With num brackets equal output is this one. You can confirm that each bracket is the same width, that they don't overloop, and that they cover the entire range from 0.0 to 1.0. Now back to the first problem. We need a way to store 8 integers using the loop variable to integrate it one at a time. By now you should be thinking list. We have to create the bracket list outside the loop because we only want to do it once. Inside the loop we will call in bracket repeatedly and update the ith element of the list. With a list of 1000 values, this code produces this bracket is 138, 124, 118, 130, 117, 114 and 131. These numbers are fairly close to 1 to 5, which is what we expected. At least they are close enough that we can believe the random number generation and is working. Now an exercise for you. Test this function with some longer list and see if the number of values in each bracket tends to level off. Now we will discuss about a single pass solution. Although this program works, it is not as efficient as it could be every time it calls in bracket. It traverses the entire list as the number of brackets increases. That gets to be a lot of traversals. It would be better to make a single pass through the list and compute for each value and index of the bracket in which it falls. Then we can increment the appropriate counter. In the previous section, we took an index I and multiplied it by the bracket width to find the lower bound of a given bracket. Now we want to take a value in the range 0.0 to 1.0 and find the index of the bracket where it falls. Since this problem is the inverse of the previous problem, we might guess that we should divide it by bracket width instead of multiplying. That guess is correct. Since bracket width equals 1.0 slash num brackets, dividing by bracket width is the same as multiplying by num brackets. If we multiply a number in the range 0.0 to 1.0 by num brackets, we get a number in the range from 0.0 to num brackets. If we round that number to the next lower integer, we get exactly what we are looking for, a bracket index. At num brackets equal 0, this bracket index. We use the int function to convert a floating point number to an integer. Is it possible for the calculation to produce an index that is out of range, either negative or greater than len brackets? A list like brackets that contains count of the number of values in each range is called a histogram. If you want to exercise, then there is an exercise for you. This is write a function called histogram that takes a list and a number of brackets are parameters and returns a histogram with the given number of brackets. And there is a glossary. In my previous two lecture, there is some word which definition is there. The immutable type, a type in which the elements cannot be modified. Assignments to elements or slices of immutable types cause an error. The mutable type. The mutable type is a data type in which the elements can be modified. All mutable types are compound types. List and dictionaries are mutable data types. String and tuples are not. Tuple, a type that is similar to a list except that it is immutable. Tuples can be used wherever an immutable type is required, such as a key in a dictionary. Tuple assignment, an assignment to all of the elements in a tuple using a single assignment statement. Tuple assignment occurs in parallel rather than in sequence, making it useful for swapping values. Deterministic, a program that does not the same thing each time it is called. And the pseudorandom, a sequence of numbers that appear to be random but that are actually the result of a deterministic computation. Histogram, a list of integers in which each element counts the number of times sometimes it happens or something happens. The pattern matching, a program development plan that involves identifying a familiar computational pattern and copying the solution to a similar problem. Now we will all know about this lecture, tuples, and their who is the unfamiliar words. I already explained these unfamiliar words, and please stay with me. Thank you everyone.